So next, let's look at the difference quotient. The difference quotient is taking your function and trying to find out the slope of that function. As you see here in the picture, we are finding 2 points on the function, connecting those with the line and finding the slope of that line. All right, now let's look at the formula here for the difference quotient and see how it works. So I have f of x plus h minus f of x all over h. Notice how this one is my function, but I add an h with the x. And this one, I'm subtracting this function. This one's a little tricky because we have to distribute this negative, as I'll show you over here in this example. So I want to find out what is the slope of this function. Well, we know this function is a linear function, and it's in slope-intercept form, which means my slope is 2. So let me see if I can plug in this function here and still end up with 2. So f of x plus h, which means I have to take this function, 2x plus 1, and instead of x, I need to add in x plus h. Here, I'm subtracting my function, which is 2x plus 1, and that is all over h. All right, so as we go through order operations, let me distribute my 2 across here. That gives me 2x plus 2h. Now, plus 1. Now this isn't just a minus 2x plus 1. This minus is actually looks, as you see here, like this 2 needs to be multiplied across this function. So I need to multiply this negative to this 2x, gives me negative 2x. And multiply this negative to this 1, gives me minus 1. And that's all over h. So let's look again how this works. F of x plus h, I need to take my function, and where I see x, add in x plus h. While the other one, basically what you're doing is you're flipping the signs on the function. So plus 2x, minus 2x, plus 1, minus 1. And now once you have all that, you just simplify it. Notice how the 2x cancels out with a minus 2x. 1 cancels out with a minus 1. And what I'm left with is 2h over h. These h's will cancel. And my difference quotient, my slope of my function, is 2. Isn't that what we said it will be with slope-intercept form? Yes. So here's how it would work with a linear function. You should just get your slope, 2. Now let's see how we can find the slope of something a little bit more difficult. Notice I don't have this in slope-intercept form. This is a quadratic. So let me use the difference quotient trying to find the slope of this function. Again, this f of x plus h, everywhere I see x, I need to add an x plus h. So I have something squared plus something. And inside there, x plus h, x plus h. And then this one, let me take my function and flip the signs. So that gives me a negative x squared. And this plus x becomes a negative x all over h. So again, taking my function, everywhere I see x, I need to add x plus h. That's this first half. And the second half, I need to take my function and flip the signs. And that's all over h. Now I just need to simplify. So I have this squared, so let me write this out twice. X plus h, times x plus h, plus, looks like another x plus h, minus x squared, minus x all over h. Looks like I have some distributing to do here. So x times x is x squared, x times h is xh, h times x is xh, and h times h is h squared, plus x plus h, minus x squared, minus x. Should have invested in a bigger board here. That should be an x. All right, now let me combine like terms. I have an x squared. Let me see, I have two xh's here, so plus 2xh. I have an h squared. My x cancel with this x. Oh, look, I have a negative x squared. That's actually going to cancel with this x squared. And then I have a plus h all over h. Now it looks like here they have h's in common. So I can take out h from each of these. So h, once I take out h from 2xh, I'm left with a 2x. Taking away one h from two h's just gives me an h. And then h divided by h gives me a1. That's all over h. Now we see that these h's can cancel or simplify to 1. And what do I have left is 2x plus h plus 1. That is the slope of my function here. That is my slope of this function.